In this video, we will focus on exit controls. We already have standard exit strategies in Plant Simulation. For the station, these are under the Exit tab. Here we can select different strategies, however. Sometimes these strategies aren't appropriate enough. In such cases, you might use a custom exit control. Let's assume we want to distribute parts to successors based on their total working time to ensure that successors are used equally. So let's build a model for that. First, we place a source and a station. Then we place two more stations and connect them to the first one. Then we will place a drain. Afterwards, we open the dialog of the station and switch to the Controls tab. Here we will create a custom exit control. To do so, we click on the three dots. Here we can now choose if we want to create a new control or select an existing one. We could also simply click in the text box and press F4. In this way, a new exit control will be created. As you can see, the exit control will be named automatically and gets the name on exit. The self in front of the name of the exit control denotes that the exit control is a user-defined attribute of the station. If we switch to the user-defined tab of the station, we will see that the exit control is placed here. We also see that there is already a line of code in the exit control. The @ is the anonymous identifier that corresponds to the part on the station. If you are not familiar with anonymous identifiers, we highly recommend you to watch the previous video. The move is a method of the part. To get additional information on this method, we can simply click on it and then press F1. By doing this, we will open the exact corresponding help page. We can see now that there are 4 different ways we can use the method. The first way is by just calling the method without passing any parameters. This is the way it is used in the default exit control. The return of this call will be a Boolean. You might ask yourself now why the method should return a Boolean. The reason is that in this way, we can check if the move method was executed successfully. So if the part was moved to the successor, then the method would return true. If the move wasn't successful, the method returns false. Based on the returned value, we can take further steps. If the move method was not successful, we could, for instance, tell the part to wait until the destination is free. If you have a connector between the object which calls the exit control and the successor, then the move method will activate the exit strategy. And based on the exit strategy, the part will be moved to the successor. The second way to call the move method is by passing parameters. We will cover parameters in the next video more detailed. For now, just keep in mind that they are arguments we can give the method. The parameters of the move method, however, are optional. The first parameter we can pass to the method is a destination. This parameter is used if the part should be moved from one object to another, and there is no connector between them. In that case, we need to specify the destination of the part in the method by passing the path of the destination object. After the colon, we can see the type that the parameter has to be. So we see that the type needs to be an object. The second parameter we can pass is a position. This parameter is of type length. This parameter is used when you, for instance, want to move the part to a specific position on a conveyor rather than the beginning. We will not go into further detail and explain the 2 other options, since you can find the explanations on this page. Now we switch back to Plant Simulation. You might ask yourself why this line of code is already placed in the exit control. The reason is that this is the default exit control, which basically activates the exit strategy. We can also see that there is a comment. Comments can be placed by using 2 slashes or 2 minus signs. What this comment tells us is that we should remove the line if the exit control is rear-triggered. If you are not familiar with trigger points, we recommend you to watch the Pick and Place Robots video. The front-triggered exit control is called when a part wants to leave the station, so the task is to move the part. Without parameters, the initial strategy is evaluated. If you already know the destination, you can move the MU to its destination. However, if the exit control is rear-triggered, it gets triggered when the rear of the part has completely exited the station. So the part would be then already on the successor, and then the move method would move the part to the next but one successor. So this comment wants to prevent a common mistake, which is to call the move method in a rear-triggered exit control. That is usually not correct since the part has then already left the current station. However, we do not want to use the default exit control and therefore delete this line. Then we insert an if-else statement from the control structures. Keep in mind that when you delete the default exit control and place control structures, that you should check if you call the move method in each branch. If you forget to insert the move method in each branch, the simulation may not continue since the part does not get the move order. What we basically want to do is to check which successor has more working time, and depending on that, the station with less working time will get the part. However, both stations have now a processing time of 10 seconds. To fix this, we will use the uniform distribution with different parameters. So we change the processing time of the first station to uniform. As always, you can refer to the help to get more information on the different distributions. Then we set the time span from 5 seconds to 15 seconds. The processing time will now be between them. In the second successor, we do the same, but this time we will set the time span between 10 and 20 seconds. After we did that, we switch back to the method. Here we want to store the 2 successors in variables to get a better overview. So we create the first variable, which we will call first successor, and a second one, which we will call second successor. What we could do now is to simply use the relative path of the stations and assign them to the variables. However, this is not the robust way, since when we change the name of the stations, the exit control will no longer work. So what we rather should do is to use the attributes of the first station to determine the successors. To do so, we open the F8 dialog of the station. Here we then type the letter S and U. As you can see, here is the attribute SUC. This attribute defaultly returns the first successor, as we can see in the signature. However, we can change the default value by passing an argument to the attribute. So we change back to the method and use this attribute to assign the successors to the variables. To access the station which calls the exit control, we can use the anonymous identifier ? In this way, we won't use any relative path and make our model robust. However, keep in mind that if you now delete a successor and insert a new one, the order of them might change. To make your code clean and understandable, you should use comments. Therefore, we place 2 comments over the lines where we determine the successors. What we then also need is the total working time of the stations to be able to compare them, since we want to distribute the parts according to the working times. So we again look into the F8 dialog. If we scroll a bit up, we can see the attribute stat working time. This attribute gives us the total working time of the station. So now we have all attributes we need to finish our exit control. So we again switch back to the control. In the condition part, we now compare the total working times of the stations. If the working time of the first station is less than or equal the second one, we move the part to the first successor. In the else branch, we move it to the second one. Now we save our changes and are ready to run the model. We insert a breakpoint at the line of the condition. Then we close all dialogues and start the simulation. Now the simulation will stop at the condition. We can now hover over the conditions and see that both working times are 0. So the first branch will be entered when we press step over. Then we can press continue and let the simulation continue. The second time the breakpoint is reached, we see that the working time of the first station is higher than the second one, so the second branch will be executed. In this way, we programmed an exit control that distributes the parts to the successor, which has less working time. You may have noticed that in the Controls tab of the station is an Exit Control Once checkbox. In the second part of the video, we will focus on this checkbox. Exit Control Once means that the exit control is called only once when the part intends to exit the object. Let's clarify what this means now. In most cases, the default behavior where exit control once is checked is all you need. But sometimes the control logic in your real manufacturing shop floor requires more sophisticated behaviors. Such situations can be handled in plant simulation with all the required details. In the following, we demonstrate a more complex example where exit control once needs to be switched off and a more detailed exit control is realized. Therefore, we have already built a second model which consists of a source, 2 stations, a conveyor and a drain. We now open the dialog of the first station and create an exit control. As we stated before, the move method has a return value, which is true if the part was moved successfully. We now insert an if-else statement. In the condition, we check if the part was moved. We can do this by simply inserting the default exit control. In this way, the move method will be executed, and based on the return value, the condition will be evaluated. If this was successful, we print part moved successfully. If it wasn't successful, we print moving the part was unsuccessful. We then insert a breakpoint and save the changes. Then we open the dialog of the second station and change the processing time to 15 seconds. Since we are using print statements, we also need to show the console. Now we start the simulation. After 10 seconds, the exit control of the first station is triggered. We make a step over step. As expected, the first branch is entered, so we let the simulation continue and can see that the statement is printed in the console. Then, at 20 seconds, the exit control is called again. However, the successor station is still working and the part can't move. We perform a step over step and see that the second branch is entered. At this point, we want to introduce the forward blocking list. MU that couldn't move to objects will be stored in the forward blocking list of this object. Since the part couldn't move to the station, it will be placed in the forward blocking list of it. To show the forward blocking list, we open the dialog of the second station. Then we click on the View menu. Here we can click on Forward Blocking List or simply use the shortcut F9. As you can see now, the part and the time it has entered the forward blocking list are stored. We then let the simulation continue. At 25 seconds, the second station has finished and is now able to process the part from the first station. When the exit control is called the third time, we again open the forward blocking list of the second station. As you can see, the forward blocking list is empty. However, the exit control was not called again at 25 seconds when the second station was able to process the part. So we can keep in mind that when the exit control once checkbox is checked, the exit control of the part won't be triggered a second time, even when it couldn't move to the successor at the first call. Now we reset the simulation, clear the console and uncheck exit control once. Now we again start the simulation. When the exit control is called the first time, we let the simulation continue. The exit control is called the second time again at 20 seconds. And again the second station isn't finished. So the part will be placed in the forward blocking list. Now we again let the simulation continue. At 25 seconds, the exit control is called again. Because the part couldn't move to the next station at the first execution of the exit control is now called again. You might ask yourself now, in which cases this might be helpful. In most cases, it is helpful that exit control once is checked. However, if you have a production line where it matters how long parts wait to be processed, it is helpful to uncheck exit control once. Let's assume that we have a production line where the part is heated in the first station and then is moved to the next station to be processed. If the part cannot be transferred immediately to the successor, this can lead to a drop in temperature, which in turn means that the part has to be heated again for further processing. Now it is helpful to call the exit control again when the second station can process the part and check how long the part has been waited to be processed. This can be simulated in the exit control only if the exit control is called again when the successor station can take the part. To model this, we reset the simulation and open the exit control. We can use a parameter in the exit control, which is of type object. The exit control will be called with this parameter if the MU was in a forward blocking list of an object. The parameter then will be the object in whose forward blocking list the MU was. If the part was not in the forward blocking list of any object, the parameter will be a void. So in the first line, we expect a parameter which we will call dest, which is of type object. Then we insert an if-else statement. In the condition, we will check if the parameter is void. This is the case if the part is finished and wants to leave the station. So we can move the part to the successor. The else branch will be entered if the parameter is not void, which is only the case if the part was in the forward blocking list of the object. So in this branch, we want to check if the part waited too long. So we insert another if-else statement. In the condition, we will now use the finish time attribute of the part to get the time when it was finished. What we need next is the current time of the simulation when the exit control is called again. So we create a variable which we will call current time. To get the current time of the simulation, we can simply use the event controller. The event controller has an attribute, which is called SimTime. In this attribute, the current time of the simulation is stored. To access the event controller, we can use the anonymous identifier root. Root is basically the frame in which we are currently. Since the event controller is an object of this frame, we can access it from the anonymous identifier root. So we first access the frame through the anonymous identifier root. Then we can access the event controller and lastly the SimTime attribute. We now go back to the condition. Here we subtract the finish time of the part from the current time. Then we insert a greater sign. After the greater sign, we can now specify the maximum amount of time the part should wait. So we insert 2 seconds. So what we did is basically to check how long the part has waited. In the first branch, we now enter what should happen if the part has waited longer than 2 seconds. In this case, we want the part to be processed by the current station again. So we move it to the anonymous identifier ? Which corresponds to the current station. In the second branch, we can specify what should happen if the part has waited less than 2 seconds. In this case, it can move to the successor, which in this case is the parameter we have passed. To keep our code clean and understandable, we now also insert comments. Then we save our changes and insert a breakpoint. We start the simulation. The first time the breakpoint is reached, we can hover over dest and see that it is void, since the exit control is called without a parameter. So the first branch will be entered. We then let the simulation continue. The second time the breakpoint is reached, the parameter is again void. If we perform 2 step-over steps, we will see that the part is not moved, because the second station is still processing the first part. The part is now inserted in the forward blocking list. We then let the simulation continue again. When the breakpoint is reached the third time, we can see that the part on the second station has left the station. Visually, it only protrudes into the station, since only the front of the part is on the conveyor. So the part in the first station is unblocked from the forward blocking list. If we hover over the parameter dest, we can see that it is evaluated to the second station. So we perform a step over and enter the second branch. The current time is at 25 and the finish time of the part at 20 seconds. So the part has waited longer than 2 seconds. If we perform a step over again, the first branch will be entered. So we let the simulation continue and the part is first processed at the station again. After the first station has processed the part again, the part is then moved to the second station. We have built the model in such a way that the part would always be reloaded to the first station. However, with a uniform time distribution, this behavior would change. This example shows the importance of the exit control once checkbox. Depending on your needs, you can model that the exit control is either called again when the part is unblocked from the forward blocking list or not. However, keep in mind that there is one exception for this behavior, and that is if the station fails or pauses during the time the part waits to be moved to the second station. In our model, this would be between the 20th and the 25th second. So if the station gets into a failed or pause state, then the exit control will be called twice, even when exit control once is checked. The underlying cause of this behavior can be illustrated with an example. Let's consider a station that handles various parts. During the station's operation, there is a possibility of failure, which can result in damage to the parts being processed. Consequently, any part affected by such a failure becomes unsuitable for further use. Therefore, it becomes necessary to exclude the damaged part from the production process. So what you could program then is to check if the station was in a failed or paused state, and depending on that, remove the part from production. This concludes our video on custom exit controls.